Scenario: a blue, red, and green sphere with the same diameter and mass are at rest on top of a ramp table. At T naught, and all the spheres are released at the same moment. The blue sphere is dropped straight down the table. The red sphere is rolled off the side of the table with a horizontal velocity, and the green sphere rolls down a ramp. What you're going to do is rank which sphere reaches the floor first and explain why. Here's the answer. The time for the red sphere, the time for the blue sphere, and the time for the green sphere. They're all equal. They will hit the floor at the same time. Why? In our scenario, when the object is dropped straight down or released horizontally or even down a ramp, notice that the time it takes to hit the ground is going to be the same. If you look at the kinematics equation and look at it in the y direction, which is how it's traveling, notice you can solve for t, which is the time it takes the object to reach the ground. This assumes that the velocity in the y direction goes to 0. Okay, and then you can now solve for t. The two things that t is a function of is the height, and the vertical accelerations are the only thing that affects the time it takes for the object to hit the floor. This assumes that the objects are identical in every single way. That's why it says here, same diameter and same mass, and they're all spheres. Notice that the time that I have here, technically it's a negative, but negative just gives you the direction. So here I'm only looking at the magnitude of the time. The time here is positive. All right? Even if the object goes down a ramp, the time value is still the same. It all depends on the height as well as the gravity. The height of the ramp is the same as the height that the red ball drops down or the sphere that goes off with a horizontal velocity.